Well, good noon, everybody. I'm glad that you were able to be here because of the weather, and Gary, thank you for introducing me. I'd like to talk about how my life has led me to this point in my PhD studies. So, as was mentioned, my name is Larwan Berke. This is my name sign. And Gary has answered what I'm doing right now. I'm a student here, pretty obviously, a PhD student majoring in Computing and Information Sciences, which we abbreviate CIS here at RIT. This is my picture from my first year here. Let me tell you a little bit about what came after that. I love this movie, these stories, and let's take that idea and go back to my life to date and see what has brought us to this point, and then we can talk about what comes next. But I do want to emphasize the experiences that brought me here. Some of you maybe are aware of this hospital. Some of you are not. I was born in Maryland. It's Prince George's Hospital. It's right next to Gallaudet University, maybe 2 or 3 miles down the road. Now it's in Maryland. It's just across the line into DC, into Maryland, not in DC. So I was born and raised there. I'm deaf. My parents are deaf. My brother came along also deaf. So the family was having some discussions about where do we go from here. I entered the Kendall School. Now, some of you may not realize that, but that's because I was only there for about a year, and then we moved to California. My brother was behind me by a year, so we moved to the school in Fremont. But there was one thing that stuck with me. This computer, the IBM XT, was born in 1983. Now, for reference, I was also born in October of 83. This one was born in March, so it's a little bit older than me, but not much. We're the same age, right? So think about it that way. I was growing and learning as this technology was developing. So now I had not experienced using this, but my father bought this to be his first computer, and I was able, as a young child, to see, you know, I'm looking at picture books, but I'm not looking at that. I'm looking at the screen that my dad's playing on, and all these images running around in my head. So technology developed, and as was mentioned, I did come to love math and numbers. You know, sometimes the family would practice and throw numbers at me. And today, if you, like me, have it go over your head, don't worry about it too much, because that's not the point. But the T on here means million, refers to a tera, and that's 1 million. So this was considered pretty fast at the time. Now, my brother was deaf, I'm deaf, my parents also deaf. We decided that we wanted to change our family situation, and we moved west. Actually, this is not our car in the picture, but I'm sure it looked about like that with all of our furniture and stuff piled on the back. So we moved to this is called the Fremont School, CSDF, California School for the Deaf in Fremont. This sculpture, this statue, is a very important part of the history there. It was created by Douglas Tilden. This is his name sign, and it was sculpted in the year 1892. So I was just fascinated having, you know, he traveled all over the world, and, you know, he had this sculpture which he donated to our school. And there, he had friends and family in San Francisco area where he was from. So now you are aware, you've heard the term Silicon Valley, that location in California where technology is just huge. Now, we moved in the 80s, so you would think that there were no tech companies at that time. There was no Facebook, did not exist. Oracle did not exist. Intuit, my parents were pretty tech savvy. No, my parents did not realize that that was what was going on in the neighborhood. I got lucky that that was where we happened to move to, into this high technological area. It was right there in my backyard, this emerging, developing field. So, you know, of course, I was able to be right there close to this kind of stuff. Going forward, my first computer was this thing, the PS1, IBM PS1, and that was something, because IBM at the time was huge, and many of you perhaps here have never used an IBM. They're not what they used to be, but at the time it was a very big computer that everyone likes to know. And Gary says, that's okay. So 10 years later, 1983, now we're talking 93, and computing had improved a bit in the field. So this one now is 80 megabytes, so you can see that it's getting bigger, it's getting faster processing with that kind of memory. Now, in the past, what I would use computers for was, of course, gaming, right? And this predated the internet. The internet was not really widely available, so I would play games on my one local machine. I loved piloting games, and then maybe some of you recognize the one on the bottom. It starts with a W, Warcraft. That was one of the first. Today, you know, WoW, World of Warcraft, and things like that. Well, this was the first one, and that's what it looked like back in the day. And then another one that I liked was One Must Fall, a boxing game that I like. So many of these are not well known today, but let me tell you what we did before the internet. Maybe you've heard of LAN parties, local area network, and you're thinking, you know, what, soda, chips, beer? No, you would bring your computer to your friend's house, your whole setup, which was a lot bigger back then, hook it all up and wire them together. And the parents were like, what are you doing, taking over our family room? What's with all these computers? And we're like, don't worry about it. You don't need to understand, but we're having a LAN party. So now this, again, is not an actual picture of my personal LAN party, but this is what they looked like. The one thing that we like to play. So we would bring it in, but it took a lot more planning. So let me tell you how we arranged for that. This is a TTY. Who here has actually touched a TTY, a teletype for communicating with deaf people? Many of you have. You're showing your age. So am I. The newer technology, people don't use that anymore. Now let me show you where my home was. Okay, you see that black spot up there? My friend and I lived not far from there, a few blocks. It was an easy walk. So I would call over the TTY. Hey, are you home? Nope, not home yet. So I would wait, call again. You ready? I'm ready. Okay, let's go. Get everything, put it on a wagon, and take off down the street to my friend's house. And we would play into the evening, and then you'd have to unplug it and bring it right back home. And then all weekend long we'd be playing with our connected computers. So now, speaking of the TTY, let me tell you a little more about that for those who don't know. The TTY uses the phone line, the landline. So now we've got cable DSL, Wi-Fi, 3G, 4G, oh my goodness, but not back then. If you wanted the internet, you would click to connect and then wait a half hour before it finally got all set up and ready to use the internet. So this was a problem for my family. They're like, why are you always using the phone line? Because my father was he had business in real estate, and he needed to be able to connect to the bank, and, you know, faxes were very important at that time, especially for my father. So I'd be on the computer and using up the phone line. So he would go just unplug my computer and plug his phone in, and I would plug the fax in. I'd be, what happened? What just happened? Oh, Dad needed to use the phone. So this was like the first deaf family to have two phone lines, one for Dad's business and one for me and my brother to use to make calls or to play games, whatever we needed to do for our social life. So of course we did use it for gaming, but that was a big part of my life, and yet it became internet over phone line, but I'll talk more about that.
And often what I would do is I would go to the library and get books and read them all the time. But my dad got tired of buying books all the time. And, you know, he always needed to have more money. And it was so exciting when we got a little bit of money, we'd be able to go and buy the books to read. And so once the internet started, we had all this new information, and there was just so much out there, and it was just too much information all at once. But it was terrific. I didn't have to ask my parents to find out information or go to the library. I could just get it right there online. It was terrific. And for me, that's how I really got into all of the computing that I was doing. And I think that all of you know this. You know, this is RIT, T for technology. So this is something that you all will recognize, that programming languages you can see here, as you see here. We have GitHub, and we have so many different ways to communicate and how to connect. It's very different than it was in the past. Now, at my school in California, it was around 1999 or 2000, what was happening was the professors prior to that time, they had all of the information. After that time, the students started to get a lot of information, especially on current communications and things related to computers. There was so much that we would learn on our own because of the internet. We were able to access it, and we would start to teach the teachers. And so we set up a T1 line in our school. We had 100,000 gigabytes per second. And for us, it was like, once I hit the school, it was so terrific. We could connect to that service. And the people within the department, information technology department, they didn't really have one. So we became that as students. We became the information technology department. And we were able to develop websites for the school. When I graduated school, in high school, you can see that 2001 was 1968. That movie was my favorite. I really enjoyed it. And I graduated high school in 2001. And that was the biggest game at that time was Halo. Prior to that, it was using Nintendo, and now we have a whole new system that we could use, the Xbox, and it was really exciting. This picture on the bottom, do you guys know who this is? I'm sure some of you do. This is Steve Jobs. Now, did he start off with the iPhone? He didn't start off with that. That was in 2007 that became popular. In 2001, he started off with the iPad. You know, myself, I never touched that. Maybe some people know what that was back at the time, but I never did. But it was a very exciting time back then. So I graduated, and I decided what I should do next. I decided I'd go off to college. I came to RIT in 2001, and I realized that I was just not ready for school. So I decided to transfer to Gallaudet and try that. 2 years later, again, not ready for school. I had a 0.8 GPA. Can you imagine that? 0.8. It's not because I was stupid. I just had no motivation. I just really wanted to get moving on to something. I'm taking classes that are the basic freshman level classes, and I already know these things. I had no motivation. It was so boring, and I crashed and burned like this plane. This airplane, actually, a couple years ago, there's a picture of an airplane that crashed in San Francisco. And it's really the same thing for me. It was the experience felt very similar. I realized I had gotten into college a little bit too soon. I needed to just take a step back and give myself some time, which is what I did. So during this time, I went home, tried to find a job, thought about should I go back to school, was trying to figure out what it is that I should do. And of course, the internet, that was my favorite thing. And what happened was I really got involved with open source coding. That means that people just write code and throw it all together in one location. Linux and Android are all things that were not yet started, really. We had Apple and Windows, that was it. So this open source coding was a new thing. And everybody was sharing ideas, and we were all able to learn from each other, and I loved it. You notice this picture on the right? People go, well, it works, but I don't know why. Or, it doesn't work, but I don't know why. I spent a lot of time trying to figure out what the problems were and how things work to be able to fix them. And I got experienced both of these sentiments, both of these feelings. And, and I realized that
Homework and school was not what was exciting for me. It was a different kind of problem that I needed.
at the time, C was the one programming language that was around. And now we have Java and Python and so many different other types of languages. And people think, see, I'm a god. I can do anything I want. But there are other people that have no idea what is going on or how to program. I have no idea what I'm doing. And I realized I need to learn more than just what I knew already. And that is what really got my motivation going to go back to school again. And I realized, I mean, in this audience, I don't really need to necessarily explain what the video relay service is, but that is something that got started. And I know that there were a lot of products and a lot of ideas on how to improve communication with deaf people. And I got an idea along with 4 other people, John Ye, Jason Ye, his brother, the father and son and his brother. And we decided to set up a business. And the business was called Viable, and this is how I sign in. When we started, there was nothing, there were no businesses like this. And so our first client that we worked with was a company called Communication Access Services. And we were able to work with them and figure out this process and develop a call center, have interpreters ready to go. We got the hardware ready to be able to actually talk with each other face to face through video phone. And it was really a wonderful service and a wonderful company. Of course, I really felt the same. Before, there was not really the video relay services. There was nothing when we first started, but then within 5 years, there were more companies were being added, and then I had nothing against VRS, but for me, it was becoming very monotone. It was the same issue happening all the time. And so I was trying to figure out what would be the best thing for me to do. So I decided quit work and travel the world for a year. I visited several different countries all over the world. And I did actually do a full world circuit, something checked off of my bucket list. And when I was traveling, I had no technology. I didn't bring any of it with me. I was on a bus for 20 hours. I didn't have, a phone to be playing and texting and doing games, etc. I was trying to figure out what it is exactly I wanted to do. And so I got rid of all that technology so I could figure it out. And during that time, I realized I really want to be a teacher. I was clear with STEM information and computers, etc., but there were not very many people that were teaching in STEM that knew sign or were deaf and were able to teach. And so I was working through the technology. I kind of learned the technology, and I was trying to get more people to work with me. And I enjoy that work in groups, etc. And so I decided I wanted to become a teacher. Now, there was one question I still had not answered. Teach what? I love math. I mean, I could teach math all day long. I truly love it. But if I'm focused on kids, kindergarten, maybe K through 12, the content is all the same. 1 plus 1. In 5 years, does 1 plus 1 still equal 2? It does. I know that says 1 plus 1 equals 3, but but I didn't want that monotony. I needed to have some new and dynamic work. And so then I thought, computers. And again, I'm not sure that I want to teach those basic classes because it's all the same information again. So I needed to figure out a different plan. So later, I decided I should get a PhD. And the reason why is because you can teach at a university level, and that's what I wanted. I want to be involved in research, I want to be involved with the students on the cutting edge. I didn't want to be talking about the basic information and all the basic courses. I would really like to be working with students at a much higher level in research, etc. But that graphic actually is pretty funny. As you start as an undergrad, you know just a little bit about a lot of different things. And as you continue through your degrees and arrive to your PhD, that's when you know a whole lot about one specific area. So I needed to figure out what specific area I would like to get into, because computers, that is a very broad field. You can get into database, you can get into compiling, into code. There's so many different areas in computing that you can get into. So I decided I didn't need to decide my specific field yet, because I hadn't finished my bachelor's level degree yet. So I decided to go back. I didn't want to go back to the exact same fields because I knew I would lose my motivation again. Now, within the STEM fields, technology is my area, but I decided to try something different. I didn't want to really get deep into the technology because I would lose my motivation again. So I decided if I was going to go with PhD level work, I needed to improve on the math skills and understanding that I already had just a little bit. So I decided to go back to that. Now, obviously, this movie with all of that, the math all over the board, that's not what I did. But I did have a really terrific experience. So where I am right now in this picture is the Willis Tower in Chicago. They actually have glass boxes that you can go out, and the floor is glass. You can stand on them and look down all around Chicago. It's really terrific place to be, and I was there for a summer internship. I was doing it with the National Science Foundation research experience for undergraduates there. And I was working with a research supervisor and also some other people who were doing their PhD research. And I was able to see how they worked, and I was able to learn a lot. Rosalie Wolf was my PhD research supervisor. We were at that time figuring out how to create avatars to work within computer animation. And I'll show you a short video. And so we're not trying to replace the interpreters. I mean, 30 years in the future, we don't know. But I was just really interested in the technology of how to make this happen. And under Dr. Wolf, I met another person working on his PhD. It was Brent Shiver. And he was working on automatic speech recognition for captioning. And as he was working on his, and I was around, I just really was drawn in to that particular work. I mean, you're talking about psychology and et cetera with people. I mean, it's not working so much with numbers. I mean, but you can't be, and I love numbers, I love math, I love working with those and having those kind of discussions. I mean, I would have loved working at IBM like Gary did. That would have been a terrific thing.
From there, I ended up in a coding competition with Google, and that was something probably 10 different universities sent teams, and Gallaudet it was great for us because we could show that deaf people could be on the level playing field, that we were able to compete, and we actually won, which was just amazing. So that was really a wonderful learning process, a great experience for me, although that was me at the time with the big fro. We've got it down to a reasonable level now. So eventually I did graduate. Now, this is what people would tell me. On the undergraduate level, compared to PhD, people were saying, boy, your undergraduate's nothing compared to what you're going to have to deal with it. You know, I had my bachelor's in math, so I thought this was really funny, this mug. I began my PhD studies here at RIT. I had applied at several different universities, but I did know that RIT would be a perfect fit because of the support systems, the deaf community, and I have enjoyed it. So when I got here, there was a learning curve, though, and this is what I found out to be true about PhD studies. You know, I can go to my lab and dive down my little research hole, and then, you know, you'll see me back home at NTID. People are like, where's Larwan? Well, one of those two buildings. So, I mean, it's a bit of a joke, but not that much. As a PhD student, I can tell you a few things that I've learned that I found fascinating too. I remember, you know, that my primary motivation at first was to teach. It wasn't so much to earn a whole lot of money, and if that's what you want, PhD is not for you. You know, people who never go to college or they're on unemployment make more than I make as a PhD student, so that is true. It's, you know, if I did nothing, I would earn more than I do. But what's not there in doing nothing, you know, is that would be really boring. I'm very interested and motivated by this, and so it's really not about the money. And if it pays $20,000, you know, so be it. Coffee was something that was part of my life in my undergraduate degree, but it took it to the next level when I went for my PhD. You know, it's like if I didn't have sleep and I didn't have coffee, forget it. It's not going to happen. If I have sleep but no coffee, you know, really, I found that you have to have both for optimal functioning. Gotta have coffee, gotta have sleep. As I have mentioned, talking about what motivated me, what kept me going, the PhD, you know, kind of went the long way. So I had left college way back from Gallaudet, but now I see, you know, it's like now I know, I feel like, yeah, I'm halfway there. So it's a big goal. I am going to get there, but it takes time. It's not overnight.
Nothing wrong with that.
And that's fine. So we've got less than 10 minutes left. Talking about my PhD work, I'm going to summarize it very briefly. So my life has taken this circuitous route that brought me to my PhD. Before I get into that, let me tell you, you know, I don't know it all. I mean, Einstein said this. It's not that I'm smart, but I stay with the question longer. I really resonate with that statement. You know, it's not that I know more than somebody else who's not as deep in my field. It's just that it's like ASR technology from speech being translated into captioning. I mean, I'm deaf. I don't have any knowledge of speech itself in that way. And then also Stephen Hawking, the famous physicist who I just adore, said, you know, in part of his life was similar to mine. He has recently passed away from Lou Gehrig's disease, ALS. And, you know, ultimately what happens is that you're not able to breathe. And my father's mother, my paternal grandmother, passed away from that as well. So I feel even more of a connection with Dr. Hawking. My PhD work, you know, in the States, there are many people where there are issues. We have interpreters to help bridge that gap between people who hear and people who do not, and people who use sign language. But in some situations, it's not practical to bring in interpreters, perhaps for financial reasons or for other reasons. So the idea behind speech recognition is that you get English words, English captioning, because I'm able to read. Now that also has its issues where, you know, if you talk about availability or cost of interpreters, the same issue applies with captioning. There's budgetary constraints, timing, scheduling, availability of a captionist. and the cost, or a stenographer. So there are different services you can get and connect to online, but again, there's a cost associated with that. And now we're in a situation where we want, I want to sign and be understood in English. I can't wait 3 hours to get that set up. So what I'm talking about is availability. We do not have an unlimited supply of interpreters everywhere. So, we cannot afford sometimes in time-sensitive situations to wait until the communication can be arranged for. And that is the motivation for this research. Automatic speech recognition, taking spoken language and putting it into caption. The computer can do that, so it's automatic, and this has been in development for quite some time, but lately it's gotten better, so I'll tell you how my work relates to that field. Sound waves, okay, see at the top, that's a picture of what sound waves would look like, and what it does is sample and try to isolate vocal frequencies from a sound wave and then come down to what has been said. And now this has been around since the 50s or 60s, the idea of making this technology work, but they were not able to have a breakthrough that allowed for them to proceed, but now we have reached a point where successes are happening. ASR is a calculation. It's not the same old 1 + 1 = 3. This is what it is. My PhD research is this right here. Only this part of the calculation that's in the red box. So it's important if we want to change it and improve it, if we can find the right solution, it'll take off. Okay, it's not on you. You don't have to do it. We're not going to, that's not what we do with our time. We're not working on the calculation. I was teasing about that. But in HCI, human-computer interaction, it's about how do humans make use of the technology that exists. If you can study both of those questions, the computing question and the human question, then you can get to the answer. Now, the reason the ASR is hot now, because I told you it started in the 50s or 60s, what have deaf people been using all this time? There are several answers to that question. And why is it taking off now? Computers in the past would fill a room, like you see the one that's in the center of the picture. This was the ENIAC, the first computer invented, and it was the size of a room. It had the same power and speed of computing that we have today, but the computing power now can fit onto this small picture that you see on a penny. So now the computing power has reached a point where we can more successfully translate things from spoken language into captioning. And with cloud computing, there's a lot more server power available as well. I mean, from someone's phone to get up to the cloud, get back, and be saved on your phone is a much quicker journey. Now we've got Siri. You can just call out to it and it'll do things. So technology is just amazing. I know that you know there, but and you know also that it can have bugs, it can have errors, it can fail, it can be down, misunderstanding can happen. So, sometimes you'll see, if you see a sentence and it's captioned successfully except for one word, then the understanding can't happen. There was one research team in France, and I like this quote that they said. It's not about that, it's that the key is the context. If you have a few key words, it depends on where the error is. If you have a few key words, then the person can fill in the gaps and understand it. If the wrong word gets missed, then, like if just one word gets miscaptioned, the reader can still understand what is being said. You can still get the gist of the conversation enough to move forward with the communication, and that is what relates to my research. Now, captioning, you've known the black box with the white words for many years. We had the idea, now of having the computer do that and assigning numbers, a range of numbers. So if you can change what gets displayed, if you can determine the likelihood of what's correct or what is not, if you can indicate, then the person knows whether or not they should trust the captioning that they're seeing. For example, with the interpreter, suppose that I'm signing and I look at them and maybe they've misunderstood what I said. It's easy for them to stop me and say, hey, could you say that again? I want to make sure I get it right. Or if you're talking to someone on your phone on FaceTime, same thing, but I need that from captioning. I need captioning to be able to let me know if it also is not confident. And this builds trust, that you can trust the captioning process and trust that the information you're receiving is likely to be accurate. If you can see an indication when it is not likely to be accurate.
Which you can trust.
So I talked about my PhD and what it was like, how I got onto this path, how I got here, the work and the process that I've been through. And, it gives the idea that it's linear, that it's just a straight path, and that wasn't it at all. Even a straight path with a slope to it, is easier than a path that's got its ups and downs, its peaks and valleys, its ditches for you to fall into. And so it's like one step forward, two step back kind of thing at times. But if you keep moving forward, it's like the guy on the bike in my picture here, if you keep moving forward. So it's the same idea for me, keep paddling, keep going, but it's not a paddle, so it's not like just one thing. I needed to be able to adapt. It's like sometimes I needed to swim instead of pedal. So, I needed to read more research, see how people did their research and learn, if I adjust the way I do things, then I can find the answers better. So it requires adaptation. It requires adapting and getting the full view of the picture that you're studying. So I am in my 4th year here, and I'm hoping to graduate in May of 2020. That's my plan anyway. So it's looking like I'm right about here. So swimming, next I'm climbing, and then I'll be done. So it's a long process, this PhD. My life has gone through things, and let me just tell you one more idea, and then I'll open for questions. I love math. I love calculations. So we have it in this simple statement here, these two statements, and most people, they look at it like, what does that mean? I don't even know what that means. So where's the hint for that? It says 365. That gives you an idea, right? How many days in a year? So okay, that's what's part of the calculation. What else? 0.99 and 1.01. Maybe that's a percentage, 99% or 101%. Maybe you get that insight. When you understand what this is attempting to communicate, it's really wonderful. My work today is 100% effort. If tomorrow I'm not able to give that much, I need to, relax. Maybe I give 99%. Now at 99%, you're still working pretty hard, right? But if that continued for a year, it would change the final outcome. You see the top number, what the result would be if I'm giving 101%. But if I can only give 99% every day, you see the very small bit of output, the small return for my efforts. So if you work a little bit harder, learn one more word, explain one more thing, small gains make a big difference. So over the course of a year, 37.8 versus 0.03 is a big difference. So that's how I view my PhD. In my PhD, it's like 1 times 1 equals 1. 1.00 raised to the 365 is still 1. 100% effort every day, this is a multiplier of 1. So you need to go a little bit above and beyond. If you do a little bit more, you'll see a difference. If you do a little bit less, you'll also see a difference. So it's important that I give my best every day, that I add to my work, move the ball forward every day. And then, let's say we're not talking about 1 year and 365 days, 4 years, that's something like 1,200 days. You can do the math yourself and figure out what would happen to these two numbers in that scenario. So I just love learning and I enjoy giving back. So I appreciate the opportunity to speak today and talk about my path, my journey, my PhD. So I've told you a little bit about my life to date and my PhD work. And now, for example, if you have questions about how my research gets conducted, let me know. I can answer those. And if we run out of time, we'll move out into the hallway and talk. I've got till 1:30, so we can continue the discussion out there if we run out of time in here.